All right, so we're going to continue 5.3, which is on partial fractions. Now, just remind me, what was case number 1? What were we doing with this today? What was it? Anybody remember? What'd you say?
Distinct linear.
Distinctly, yeah. Distinct linear factors. Okay? So we're going to do case 2 today. Case 2 is going to be repeated linear factors. I wonder if I should give you all the cases today. Maybe I'll do that really quickly and hopefully we'll have time to go. So there's going to be 4 cases. So repeated linear factors. Let me give you an example of a repeated linear factor. So let's say, for example, I had x squared plus 1 over x times x minus 1 to the 3rd power. Okay? Now, if we were setting this up with case number 1, it's going to be similar, but there's going to be an important difference here. So if we were doing this with case number 1, how would you set this up? Sarah, it must be your turn.
I'll set it up.
How would you set it up?
Well, I'll try to factor it, but I don't think the top one. I'm trying to think how to factor it.
Okay, this is a linear factor, correct?
Yeah.
So you're going to have an x, right? Now, this is a linear factor, but it's repeated. Do you see that? Okay, so here's going to be the difference. Because it's repeated, I'm going to put x minus 1 here, and then I'm going to do x minus 1 squared, and then I'm going to do x minus 1 to the 3rd power. Okay? So, I'm going to add all of those together. Now, in the numerator, what do you think we should put in there? A, B, C, and D. Okay? Now, the rest follows exactly the same. What I'd like to do is I want to give you all the cases, and then we'll do one at the end, at least one. Okay, question?
How did you get those last two? See?
Okay, so you see that this is a repeated linear factor.
Yeah.
So I'm going to put the linear factor, and I'm going to repeat it until I get to here.
Oh, okay.
So I've got x minus 1 to the 1st power, x minus 1 to the 2nd power, x minus 1 to the 3rd power.
And if it was to the 4th power, there'd be E on top.
There would be an E over x minus 1 to the 4th power, right? Okay? So that is case number 2. Case number 3, we're going to have non-repeated quadratic factors. Okay? In this case, let me give you an example. Let's say that I have 2x squared minus x plus 4 over x cubed plus 4x. Now the first question is, can that be factored? Din, can you factor that denominator?
X cubed plus 4x.
Yeah.
What do we call this?
You can pull out an x, right? To pull out an x, what's left?
X squared plus 4.
X squared plus 4. Is that factorable? No, it's not. Okay? Now, I've got a linear factor here, and I have a quadratic factor here. Okay? So, under case number 1, how would you break this up? Eric, what do you think? How would you break that up?
Over x and over
Something
x.
over x. plus something over
X squared plus 4.
x squared plus 4. So that's going to stay the same. Okay? Now, this x is a linear factor, so what should I put up there? An a. This is a quadratic factor. Okay? So here's the difference. This is where we're different, okay? This is a quadratic factor. When you have a quadratic factor, you have to go down 1 degree in your power. So I'm going to put bx plus c. Okay? And so that's the case of a non-repeated quadratic factor, okay? Bx plus c. Okay? Everything else you're going to do the same. And finally, let's do case number 4. Okay, case number 4, what do you think it's going to be? Repeated quadratic factors. Repeated quadratic factors. Okay? So an example of this one would be, oh, this is a really good one. Yeah, I like this one. Okay, so let me do x to the 5th minus 3x squared plus 12x minus 1 all over x cubed times x squared plus x plus 1 times x squared plus 3 squared. This is going to be a long one. In fact, you can kind of see everything's backwards though. Okay. All right. So we need to break this up. Now, what kind of a factor is this one? Mary, what kind of a factor is that? You don't know? Noki?
Is it quadratic? What's the question?
What kind of a factor is this first one?
Yeah, I don't know.
Eric? Sure. What kind of a factor is this first one? Sam, save me.
What do you require about, like, what kind?
Is it linear or quadratic?
Oh, it's quadratic, yeah.
No.
It's not.
It's a linear repeated factor, correct? Do you see that?
Yes.
Okay, so if it's a repeated linear factor, how do I break that one factor up? Something over x plus something over x squared plus something over x cubed. Okay? Now we've got this second factor. What is this? It's definitely a quadratic. Plus something over, that's not factorable, by the way, x plus 1. Plus, what is this?
That's quadratic.
That's a repeated quadratic. So what do you think we do with that? That's going to be something over x squared plus 3 plus something over x squared plus 3 squared. This is going to be a long one. Okay? This one almost makes me want to solve it. All right, so let's see here. What should I put here?
A.
A. And B. And C. And dx plus E. And
fx plus g,
fx plus g. And
hx plus I.
hx plus I. Now this is a good one because how many equations are we going to have? How many unknowns are we going to have? 1, 2, 3, 4, 5, 6, 7, 8, 9 equations and 9 unknowns. That's what I'm talking about.
Why?
Okay, we're not going to stop at just 3. Why stop at 3 when you can have 9? Okay?
When we're talking about cars, then yes.
All right, so here's what I'm gonna say. If I were to give you something like that, I wouldn't make you solve all 9 of them. That would be the whole test. Maybe I should do that. How about that? This would be the next question.
Sounds
One
painful.
question.
No, that means you
Let's
can
do it.
give you this one and then they.
One wrong and you mess up the rest of it.
Yeah, don't A plus H this one, okay?
Okay?
I
Yeah.
hate that one.
Yeah, that would be good. Well, yeah, that's actually not a bad idea. We'll do the derivative formula here. F of x plus h minus f of x.
Dang.
That would be good.
No.
Maybe we'll make 2 questions. All right. So do you understand the different cases here? Case 2, repeated linear factors. Okay, so you're going to repeat them. Case 3, quadratic factors. You drop it by, didn't mean to erase that. You drop it by a degree of 1. And then repeated is kind of a combination of cases 2 and 3. Okay? Now, we've only got, 8 minutes left. Tell you what, we'll go back to this one here, and we'll solve it. Do you feel comfortable solving, well, maybe not 4, but do you feel comfortable solving 3? Do you feel comfortable setting up 4?
No.
No?
With practice.
With practice? We talk about practice.
It's not bad.
I'm going to have to show the Allen Iverson thing. All right, let's do, I'm going to erase the bottom here. Let's go ahead and let's finish this one here. Because this one actually has 4 equations, 4 unknowns, right? Okay? All right, so what would we do? Let's see, whose turn is it? Max, it must be your turn. How would you start out on this one? What do you multiply that by to get this? 1 cubed, right? X minus 1 cubed. What do I multiply this by to get that?
X.
X and
X.
x minus 1 squared, right? 1 squared. What do you multiply this one by?
X.
X minus 1. X minus 1. And this one? Just plain old x over x. Okay? All right. So here's what we're gonna do. I'm gonna do the x minus 1 squared. Okay, so x minus 1 squared is x squared minus 2x plus 1 times, and then I'm gonna multiply a times x minus 1 to give me ax minus a. Are you with me? I did x minus 1 squared to get this, and then I did a times x minus 1 to get that. Okay? Then I'm going to do bx times x squared minus 2x plus 1 plus cx minus cx squared minus cx plus dx. And I'm not going to keep writing the denominator because I don't care. Now I've got common denominator. Okay? Now we're going to FOIL this. This is going to be ax cubed minus 2ax plus ax minus ax squared plus 2ax minus a. Now we're going to do this one plus bx cubed minus 2bx squared plus bx. And then plus cx squared. Here, you know what I'm going to start doing? We're going to start, well, I should have done this sooner. Minus cx plus dx, okay? All right. I should have done this in a different way, but this was fine, okay? So let's start with the x cubed, okay? I'm going to find all the coefficients of x cubed. So that's going to be a plus b, that's it, right? A plus b, what does that have to equal? What's my x cubed term here? 0, okay? Now I need to do my x squared case, okay? All the x squared. So I've got negative a minus 2b plus C. That's it. Okay, what is the coefficient of my x squared term?
1.
Equals 1. Now I need to do my x term. My x term is negative 2a. Oh, negative 2a plus a is negative a, sorry. Negative a. No, wait, is that right? Yeah, that's right. Okay, so negative a plus 2a, oh, that's weird, is a, positive a. Well, we get a lot of those there. Okay, the x term here, plus b, minus c, minus c plus d equals minus c plus d, okay? What is the x term here? 0. And then I need to come up with my number term. Okay? The number term is negative a. Oh, that's it. Negative a, what does that equal?
1.
Negative a equals 1, so a equals negative 1, correct? So this first partial fraction is going to be negative 1 over x. I already know that, okay? All right, so that's nice. A equals negative 1, so therefore b equals 1. So that's going to be plus b, that's just plain old b, right? Yeah. So plus 1 over x minus 1, okay? All right, so a is negative 1, b is 1. So we can do this one now. So negative 1 is going to be positive 1. Minus 2 times 1 minus 2 plus c equals 1. So that's negative 1. So if I add 1, c equals 2. Okay. So c equals 2. That's going to be 2 over x minus 1 squared plus. Okay. So now a equals negative 1. Now we're going to use this one. So negative 1 plus b plus 1. So that's going to go away. Minus c, minus 2, plus d equals 0. So I'm going to add 2. D equals 2. Okay, so my final fraction here is 2 over x minus 1 cubed. Okay? See how easy that was?
I can.
I don't think it.
Okay?
It's good.
All right.
Okay.
So, Val and I said, we talking about practice. Okay? So go practice. And the quiz will be on either case 2, 3, or 4. Probably 4. Maybe I should make case 4 the one. So we just make that the quiz tomorrow?
Yeah.
That might take the whole class. Maybe I'll see if you can set it up. Okay, that's fair game. That won't take that long. Okay. All right. So see y'all tomorrow.